So remember, this is all about you. We want you to be sitting there with your pen, with your paper, smashing out some of these examples and doing some of your own as well. So you've got the first example. It says, for the following, state the exact solution and the solution to 3 decimal places. And we've got 3 to the power of x equals 7. So intuitively, we kind of know that 3 to the power of 1 is equal to 3, and 3 to the power of 2 is equal to 9. So we know that this solution here for x is going to have to be between 1 and 2. So it might be like, maybe if you were to have a guess, it might be like 1.75, maybe, roughly. Okay, but I want to know to 3 decimal places and exactly. So if we remember, if we've got a to the power of x equals b, there's our equivalent statement is that we've got x being equal to log base a of b. So here we can more or less just directly derive and say, well, seeing as x in the power, then I know that I've got log with a base of 3, 7. Okay, that is my exact solution. And you can go ahead, you can put this in your calculator and you'll get an approximation of x being roughly equal to 1.771. You go, cool. So if you were to go ahead and check this by putting it into your calculator, what you do is you'd say 3 to the power of 1.771 is equal to what? And if you were to put it into your calculator, you would get 6.99807. So you get an approximate answer, but personally, I like to be exact. So this is where our exact solution comes in. If you put out your calculator, you went 3 to the power of log base 3 of 7, you would get it directly equal to 7. Okay, so here we're going to deal with an example that doesn't exactly necessarily deal with a direct translation of 3 to the power of x equals 7. Okay, we can see here we've got x's on both of the powers. These get a little bit more complex, but they are manageable. In this situation, what we want to do is we want to just take the log of both sides. So that's what I'm going to do. I'm just going to say log base 10 of both sides. Okay, and then we go ahead and from here we can apply the third log law to get those x's that are in this compartment here down out into the front. Okay, so here we're apply third log law. Okay, and what we're going to do here is we've just got our left hand expression. We're just going to expand that. Alright, and in order to solve for x here, we need to get all of the x terms onto one side like we would in a normal algebraic expression. Okay, from here, we're going to use some simplification processes. So on this left-hand side here, this 2, I'm going to do the reverse of the third log law. So that 2, I'm going to pump it back up on top of there. So I'll say here I've got log base 10 of 4 squared, and that's going to be equal to, and so here both of the terms on the right hand side have got an x included in it. So I'm just going to factor that x out. Alright, and then just continuing to simplify here, on this side here I've got log base 10 of 16, that's what 4 squared is, keeping this x on the outside. Again, I'm going to, as I'm simplifying, just do the reverse of this third log law to chuck that cubed back up there. So I've got log 10 of 4 cubed plus log 10 of 7. Okay, I'll continue to simplify this one here. Alright, what I've got is log base 10 of 16 being equal to x outside of log base 10 of 64 plus log base 10 of 7. Alright, continuing along, I can apply the first log law to simplify these two log terms, log base 10 plus log base 10. You multiply those two terms here, 64 and 7, when you bring those together, okay, that's applying the first log law, we get log base 10 of 64 times 7. last step here, just divide by log base 10 of 448 to get x by itself. So you've got log base 10 of 16 divided by log base 10 of 448 being equal to x. And this here is our solution. That's our exact solution. Right, you can go ahead, you can plug that into your calculator and you'll get a decimal approximation of x being roughly equal to 0.454. Okay, just while we're on this note, we're going to go through question 8b and 8d from your textbook. These ones are hard, okay, but there are some simple tricks to just simplify them out. Alright, so here we can see solve the following for an exact equation. 5 to the power of negative x minus 5x equals 4. And you can go ahead, you can pause it, you can try and give it a crack, but if you go straight into just plugging in logs, taking the log, you will get there, but it'll take you a bit of time. What I'm going to spot is I'm just going to use something over indices. Okay, if I've got 5 to the power of negative x, that's the same thing as saying 5 to the power of x, and minus 5 to the power of x equals 4. And I'm going to use a good old trick of substitution. I'm just going to say let 5 to the power of x equal k. And when I do that, I actually get 1 on k minus k equals 4. Now this very quickly becomes quadratic when I decide to multiply both sides by k. Alright, what comes out is this first time becomes 1, that's minus k squared, is equal to 4k. Okay, this is a quadratic I can just directly solve. So I'm going to go ahead and do that. Necessarily factorize this one easily. You could apply the quadratic rule to get solutions for k. I'm going to complete the square just to get an exact solution. Okay, and so here, once you solve it, you get two solutions for k, which is negative 2 plus root 5, and then negative 2 minus root 5. Now, these are solutions for k. Okay, remember k is equal to 5x, so now you substitute back. Okay, you say that you've got two solutions here. You've got 5x equals negative 2 minus root 5, or 5 to the power of x is equal to negative 2 plus root 5. Now, we're going to need to reject this solution here. Okay, because 5 to the power of x cannot be negative. And we're going to accept this solution here and continue to solve for what x would be exactly. Okay, so we just apply a direct translation of log indice to log, and we say that we've got x being equal to log base 5 of, and I'll write it with the square root first just because we want to have our positive term first, square root of 5 minus 2. And this is our exact solution. That's it. So just a bit of substitution. Okay, here this is 8D from your textbook. It looks much harder than what it actually is. Okay, we can see here, first thing I spot is that all of the bases are the same. So you can apply some log laws, which is nice. Okay, and you don't have x's in the power. You've got them inside the logs, so you don't have to apply logs to an equation. Okay, the logs are already there. We're just going to go and we're just going to simplify it. All right, we're going to simplify this first part by applying the first log law to these two terms here. X cubed multiplied by x squared. Okay, then I'm going to subtract. I'll do the reverse of this third log law here. So you get minus log base a of 2 to the power of 4 being equal to log base a of x. So just a bit of simplifying here. Alright, we know that this is just x to the power of 5. Okay, subtract log base a of 16 being equal to log base a of x. Alright, here we can apply the second log law to our left hand side here, and here it's kind of sneaky, but we've got some deduction to do here. Sneaky. Log with the base of a of this thing is equal to log the base of a of this thing. So that means that these two things have to be equal. So therefore, x to the power of 5 over 16 is equal to x. Sneaky, right? But that's fine. We can just solve that. So that means x to the power of 5 is equal to 16x. So x to the power of 5 minus 16x is equal to 0. Okay, this is just simplifying and solving it. You can factor out an x. Get x to the power of 4 minus 16 equals 0. So then you can say by the null factor law, you've got x being equal to 0 and slash or x to the power of 4 minus 16 equals 0. So x to the power of 4 equals 16. So x is equal to the 4th root of 16, which is just 2. Okay, and it is tempting to just stop here because you're like, I've done so much work, right? I'm done. Okay, but we need to analyze our solutions. Are they acceptable? Do we need to reject any? Okay, and we are going to have to reject this guy here. And we're going to accept this one here. Okay, and we're going to reject this one here. I'll do my reasoning in a green, okay? Because in our initial question, this existed. Log base a of x. Okay, log base a of 0 does not exist. That's your reasoning. That's why you're rejecting it. Okay, and it makes sense when you think about it. More or less, what this is saying is a to the power of what is equal to 0, and nothing, right? Because even if you have a very, very negative power, you get a fractional answer. It never goes to 0. So you need to reject that one, and you go ahead and you accept this one.